Okay, so dilation. So the word dilation, if you think about it, maybe a time that you've heard of dilate is your pupils that dilate. So when you enter dark versus light spaces, they get bigger or smaller. If you never knew that, check it out sometime when you go from like a dark room to a light room. So dilation means things getting bigger or smaller. So when it says dilate by a factor of 2, it means we're going to increase the size by 2. It's going to be 2 times the size. In this case, about the origin means that this is the point at which we're growing it from here. So this length here, and this length here, they're all going to be stretched by a factor of 2. So like that line will now be like out here, this one will be out here, this one will be like here, and now our new shape is going to look something like this. It's all coming from the origin. There are other places that you can dilate from. We're only going to, for our purposes, we're looking at dilation from the origin. So what does that mean? If I dilate by a factor of 2, so our K value was 1, 1. So our K prime is just going to be 2, 2. Why 2, 2? Because 1 times 2 is 2. And 1 times 2 is 2, right? Okay. Now our J value, so our original J value was 2, 4. So if we take that, if it's 2, 4, and we multiply it by a factor of 2, it's now going to be 4, 8. So our new J value, okay, is going to be 4. 1, 2, 3, 4, 5, 6, 7, 8. This one's a bad example because it does not have your labels for your y-axis, and it should. But this is where my J prime is, okay? And my L, my original L was 4, 0. When I dilate that, 4 times 2 is 8, and 0 times 2 is 0. So it stays at 0, but it's going to be here. And I have a combination of red and green. That's okay. My new shape is going to look like this. So it's the same. The angle principles stay the same. The angle degrees here, the number of degrees here, and then they're the same. The number of degrees are the same. It's just we've stretched the sides. But the ratio of the sides in this would be equal to the ratio of the sides in this. It's just this side is going to be twice as long, and this side is twice as long, etc. Okay? All right, so let's look at this one. So this is slightly different. We're dilating by a factor of 1/3. So think about it. If I had something and I multiply it by 1/3, although I'm multiplying by 1/3, it's going to get smaller, right? I mean, it's like I'm dividing by 3. Multiplying by 1/3 is the same as dividing by 3. So each point, I'm going to shrink it. So my original M, which is up here at 3, 9. Okay. When I shrink it or multiply it by 1/3, it's now 1, 3. My original N, which was 6, 0. When I divide by 3 or multiply by 1/3, it's going to be 2. The 0 doesn't change because 0 divided or multiplied by anything stays as 0. My O, which was 3, -6. When I multiply, oops, that shouldn't be O prime there. Thanks. Okay, no O prime. Just O. Okay, the O prime is now 1, -2. So 1, -2. Oh, I didn't graph them. I'll graph them after. And my P, which was -3, 0, becomes -1, 0. So now if I were to graph those, 1, 3 is here. That's my M prime. 2, 0 is here. That's my N prime. 1, -2 is here. That's my O prime. And -1, 0 is here. That's my P prime. And now my shape looks like this. So I've shrunk it down. Again, the angles, this angle here and this angle here are the same. But the length, this length and this length are 1/3, right? So whatever this is divided by 3, I get this one. And that is a dilation. So what does that mean? When we dilate by a factor in math, we call it a factor of K. All we're going to do is take that K value and multiply by the X value. Take the K value and multiply by the Y value. When K is bigger than 1, like here, a factor of 2, our shape got bigger. Whoops. Bigger starts with a B, not a G. Bigger, larger, whatever. Okay? When K is between 0 and 1, like here, our figure got smaller, or it shrinks. Now, something really interesting here you're going to notice, you don't see a negative here, okay? Because if there was a -2, if we did a factor of -2, that's actually a combination of a reflection here, right? The negative in front of something is a reflection and a dilation. So be careful with that. So that's why you're only going to see between bigger than 1 or between 0 and 1, because as soon as there's a negative involved, it's a combination of a reflection and a dilation. Okay, so that is a summary of dilations.